start. Oh, which one we want to play with first? I think we'll play with 32. So, part 2 of the Unit 2 preview. So, each mapping represents a relation. Determine the domain and range and if the relation's a function. Okay. Remember from yesterday, we kept saying whenever there's a bunch of numbers listed, chart, coordinate points, or what our mapping is here, all I'm looking for is to see if the x's repeat. So if I look at the x's, you're like, well, like, I don't see any numbers repeating. Is that what you mean? Yes, but what I'm looking mainly for here is when you're looking at these, if I were to actually follow the arrow, I could make coordinate points out of these. And so now, does it mean that you have to do this? No. But if it assures that you get the right answer and the right idea, I don't think it's a terrible idea. Because now I can look and say, okay, yes, all my x's were different. I didn't end up with a repeat of like 2 arrows coming out of one number. So yes, this is a function. That's for sure. For my domain and range, again, refer back to the last 2 sections that we did. My domain, since I have a list of the numbers, they're not connected, there's no arrows, nothing like that. All I've got to do is list off my domain, my x values. And I'm going to list off my range as my y. That's it. That's the one nice thing about this test coming. There's a lot of stuff that just goes quick and can be easy if you've done any practice at all with it to kind of see how it works. But now, this last part we're going to do, though, okay, we are going back. Oh, we got one more relation part. I forgot that. So, you're like, wait, what's even on here? Let me make the dots a little bit more visible here. Okay, I'm going to do 35. So, the vertical line rule is still in effect. So as I go through, if I stop when I see a point, it should still only be going through one point. If I get to a spot and it goes through 2 points, that's bad. That's a repeating x value. So that's not a function. If I went through and I only saw 1 at each time I stopped, I'm still good. So my domain and range, hint, hint, I put braces. You're like, but it's a graph. But they're not connected, and you're not allowed to connect them randomly because you want to, okay? So here, I'm just going to see where each of my dots, what their x value is. So let's see, we're between 2 and 4, so that'd be 3. And here we're right on 6. So my domain would be those 3 values, because 2 of them have a repeating x. And then I'm going to use the same ones for y. Again, follow it to the y-axis. Follow it to the y-axis. And just keep jotting those down. So you'll notice I have fewer domain numbers than I do range numbers. That'd be another hint it's not a function. But even if you didn't notice that, that can occur sometimes, and vice versa. Now the rest of it is going to be graphing options here. So, graph the equation. What's the vertex? Okay. So, reminder here. And again, we've got this in the notes, and I'm going to write that down here in a minute. If I go to the notes, there we are. What page is that? Page 13 of the notes. There it is right there. There's my directions. I'm going to re-jot them here, though. But that's going to help me in the next part. So let me do a little updating here with my up, down, and left and right. We'll talk about the stretch too, but right now we want to keep life simple. And so when I'm looking for my vertex, okay, my vertex is the center of my graph. Okay, how do I find the center of my graph? The center of my graph is this h and k value. So it's these two. So let's say we're doing number 36. And we're like, okay, so Hardy, is it -3 and then, I don't know what's going on here, but is that -3? No. +3, because this is the opposite of what h is. That's what that minus or negative is. So the opposite of -3 is +3. And if there's nothing on the outside of my absolute value, that's going to be 0. So, if I wanted to, I'm going to show you two ways to do this, and it looks like I'm calculatorless again. One way you can do it and make the rest of your graph, there is always a number in front of your absolute value. In this case, it's 1, since I don't see 1. That's like our slope. But now, instead of just going up 1 and right 1, because that would just make a line, we go up 1 and what we call over 1, because we go both directions. And we make this V shape, and I can get my graph. But let's say you're like, yeah, me and pattern stuff, I'm gonna end up making a line if I do that. This isn't going to be good. Okay. The calculator can still help us. Now, this you will need to know tomorrow if you want to do something, unless you have it in your notes, and you might. But I'm not going to tell you when you come up, how do I put this in my calculator? I'll be like, no. Okay, so if you want to go calculator route, all you got to do, if you want those bars, is go to math over 1 to the numeric column, num. Somebody like math makes me numb. Okay, number 1 is absolute value. There's my little bars. X minus 3. And what you can do then is you can pull up the chart or the graph. Second graph gets me this table. And if you get your vertex in the middle of your chart, there's my 3, 0. You're going to see the exact same numbers above and below. You're going to be like, all right, so I got 2, 1, I got me 4, 1, got me 5, 2, and I got me 1, 2. You got the exact same points I did using the slope of sorts. Either one works, but you got to be able to do one of them. So be prepared, because that's something we've got to be able to do. Now, let's take that one step further. Let's find one where there's lots going on. Okay, here we go. Let's do 39. Now 39, ooh, I got different questions. Okay, so graph the equation. What is the domain and the range? What are the shifts? What are the transformations? Okay, so first things first. Hardy, we got a disappearing act again here. There's nothing inside the absolute value with my x. Okay, let's fix that. If there's nothing in there, stick 0 in there, just like we did when there was nothing on the outside. So if that's true, my vertex would be at 0, because we can't have -0 vertex. That's kind of weird. 0, -1. Okay, I got my first point. Hardy didn't ask me for the vertex. Well, we needed to graph it, so I'm just going to write it down. What are the shifts? What are the transformations? Okay. We wrote them on the other side, but I'll just pull them up here on my notes. So here, I didn't go left or right any, but -1 on the outside means I'm going down 1. But Hardy, you got 2 blanks here. Why you got 2? That 3, and we've talked about this before, makes my graph stretch. If there's an A value besides 1, it's going to make my graph either get skinnier as the number gets bigger, or it's going to make it get wider as the number gets smaller. So if there's a number in front, it stretches. So how does that help me? When I go to graph this, if I don't want to use the calculator, and I'll show you how still, since my a value is 3, or 3 over 1, I'm going to go up 3 from the dot, 1, 2, 3, and over 1 both ways. 1, 2, 3, 1, 2, 3, and over 1. So you'll notice my v is skinnier on this one than it was on the last one that we did. But I know, especially when you're taking a test, sometimes the pressure can kind of get on you. So you're like, all right, what do I got to do if I want the calculator to do my thinking for me here? So I got my 3 first. Math, num, number 1. There it is. X, now be careful. The minus 1's outside of the absolute value. If I just type minus 1 right now, it's going to be inside. So if I want to go out, I got a right arrow out, then minus 1. Otherwise, it's not going to be pretty. Second graph. And here's the other good thing about knowing my vertex in advance. I just had it shown to me I was right because I see the exact same numbers above and below. And check this out. Negative 1, 2, there it is. 1, 2, there it is. 2, 5. Negative 2, 5. Boom. So you have options. Lots of options. And then domain and range. We talked a lot about this before too. Domain, x values from left, forever left, to right. Every single time with absolute value. Opens up, opens down, stretches, shifts, don't care. Don't care. It's always infinite. Now range, we got to think a little for our y's. We do go up forever, but I don't go down forever. Negative 1. Which just happens to be the same as the y value of my vertex. You know, no coincidence there. No coincidence at all. So that's just understanding verbiage. Okay, what does shift mean? Oh, it's this stuff on page 13. Okay. You might even want to put something in there with this stretch on A. I think we have it somewhere else, but if we don't, kind of want to do that. And then we're doing the same thing, but notice, not absolute value anymore. I just want to look at them quick. Ooh. Let's do one of the trickier ones. Let's flip. We're going to do 43 and 44, and then that's the ones I want to make sure I cover. But if we need to go and do something else, we can. So, just as a heads up, your up, down, left, right has not changed. So just as an FYI, you're like, wait. So what you're trying to tell me is my shifts and all that other stuff are the exact same for these radicals as it is right here. Yes, that's what I'm telling you. I'm telling you that if I look at a typical one of these, this is still left and right, and it's still the opposite of what we think. This is still up and down, and that is still my stretch. So you kind of get 2 for 1 here. Nothing's changing. The only thing that's changing is what points I'm going to be plotting. And we'll chat about that because you have options here too. I love options. Options make things easier if we use them correctly. So now 43 is trying to trick us. You look at that, you're like, oh, it must be the A value. It's in front. Why is this plus here? Okay, let's do this. If you see stuff in front like that, not like a number that's just sitting in front, Like, see that 3? Nothing in between. That's a stretch number. That's not a stretch. So let's do this. Let's make it look more normal. What I just wrote in blue is the same thing as what's up above there. You can leave it the other way, but you don't have to. I think it makes this a little easier. So if I'm looking at my transformations first, which two directions am I going for? Minus inside. Minus outside. So here's why that's important to us in the graphing part. If I start at 0 and I go right 4, and I go down 4, that's going to be the first point of my graph. I'll guarantee it. Let me show you. Oh, Hardy, how do we do this radical thing? Okay, this one's right on your screen here. It's right here above the x squared, that little blue. So second and x squared will get you the radical. X minus 4. If I just keep typing, minus 4. Uh-oh, it's all under the radical. Not good. Not good. Don't want that. To get out, it's even telling you how to get out. Go to the right. Get that up. If you pull up your chart now, error, 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 error. What's the first thing right after error? 4 and negative 4. The point that I just plotted. Wasn't that convenient? So I'm just going to kind of make a quick little one of these. So negative 4. Oops, I just did it the opposite. It's 4, negative 4. Got to get the points right. We also have 5, negative 3. And 8, negative 2. Those are the only ones that are going to fit on my graph here. So 4, negative 4, 5, negative 3, 8, negative 2. And when you graph these, it's only arrow on the right. We're not doing arrows both directions here. Like it starts, let me get a normal graph here for a minute. Yeah, that doesn't keep going. That literally stops right there. And so here's the other cool thing that we talked about before. My domain and range, I'm given where they start. It's the first point. That's why I like to make the chart. Because my domain starts at 4, forever to the right. My y starts at negative 4, forever to the right. If you find those numbers, that first pair that's right after the error messages, there's the start of your domain and range. I actually like the calculator for once when we're doing these because it lets me get all this stuff done. So, kind of a nice thing to see. Now, the last one I'm going to take a peek at, and I'll do others if people want them, is dealing with a cubed root. Oh dear. This time we only have one shift, one transformation. This plus 4 on the outside. So we're going to be going up 4 is my only transformation. So I'm going up 4. So let's test the theory out here. Okay, if I go up 4, I'm at 0, 4. All right. Now, is that going to make a difference when I do it this way? Well, let's find out. Hardy, how do I do cubed root again? We're back to math. And check it out. It's right on this page. Math number 4. If you don't have these things in your notes, put them in there. It's legal. So I got my cubed root of x. Plus 4 is outside. Make sure you get that arrow to the right. Plus 4. Pull up my chart. And I'm like, Hardy, there's no error messages now. What do I do? Okay, if there's no error messages, that's okay. We're still going to go ahead. We're going to jot these numbers down, at least the ones that are going to fit. Let's see what we get here. Gosh, I'm getting quite a few. I might even get one more. Woohoo. Okay. So I took those straight from, just the whole number ones. I don't like decimals. Decimals are no fun. So, get there. And what I'm going to end up getting, my graph, is going to kind of slither its way through here. Whoop, there it goes. When I have cubed roots, that's what my graph is going to look like on all of these. It might go up, down, left, right, but it's going to look like not a halvesy, it's the whole thing. And the nice thing about these, my domain, forever left, forever right, every time. And my range, now this isn't quite as obvious. This is slowly sneaking upward, not real steep. This is slowly sneaking downward, not real steep. Every time. If it's a cubed root, not a square root, just cubed root, my domain and range are both going to be infinite, no matter what. And I believe, oh no, I believed wrong. I forgot, there's one section left. I'm like, I believe that's the end. I was wrong. That's terrible. I'm the guy that made the review, and I thought I was done. I have one section left. All right, let's see what we got to play with here. Let's do 47. We'll wrap up with 50. I appreciate your patience, but I'm telling you, it's going to be worth it going through this. You're going to bust through this and be like, this is easy, Hardy. Okay. Solve each equation. Remember to check for extraneous solutions. All right. First job. Get your radical alone, if it's not already. And not alone. I'm multiplying it by 4. We don't want to distribute or do anything crazy like that. So we're just going to divide by 4. Once that radical is alone, we got to undo it. The house has got to come down. So the opposite of square rooting, remember that little 2's there, is to square both sides. And again, 5 squared is not 10. This isn't exponent rules. We're not doing 5 times 2. And then I can just do my division and go about my way. But I will remind you on extraneous solutions, especially if you get a negative for an answer, take a minute to check it. 5 times 5 is 25. The square root of 25 is 5 times 4 is 20. Okay, that worked out well. That's okay. I did good. Well, but what if there's 1 on each side? Is there only 1 on each side? As long as there's only 1. Let's go ahead and square those to get rid of their little radical houses. And we're back to Algebra 1. Now, will I admit, I think this would be a whole lot easier for some of you on this test tomorrow if some of you would have practiced more than you did. Yeah. But do I think you can still get the job done and do okay, even if it's just finishing up some of the other ones we didn't, to get you some practice now that you've kind of allowed yourself to rehear everything? Yeah. 7 gonna work. 8 minus 7's 1. 14 minus 13's 1. Yeah, that one worked too. That one worked too. So as I was saying, let's see if I can pull that up while I'm still recording here. Maybe. Maybe not. See, currently now on the screen is, if you need any of the notes that I've referenced here, here's the PDF. You can get those. Here's the preview just answers to be able to check as you go. Here's the video from yesterday, and I'll post this one too, in case there were some pieces you missed. You're going back later going, why did he do that again? And you can kind of see how that works. So